This is not a chatbot pretending to solve every support problem. It is a focused AI system with one job: send each ticket to the right team. Clear billing, account, and technical requests move automatically. A mixed request stops for human review. In 10 minutes, we will build the complete pipeline from start to finish with LangChain Azure OpenAI, retrieved evidence, structured output, and a safety threshold. A keyword rule works until language becomes messy. A customer can describe a login problem without using the word login. Another ticket may mention a password, a crash, and a payment in the same sentence. Adding rules creates more edge cases. We take a different path. We provide labeled examples of realistic requests. An embedding model converts their meaning into vectors. For each ticket, we retrieve 5 close examples. A chat model makes a constrained decision from that evidence. The scope stays narrow: 1 ticket in, billing, account, technical, or human review out. Narrow systems are easier to inspect, test, and improve. Here is the complete architecture. We begin with 60 synthetic tickets, 20 billing, 20 account, and 20 technical. Azure converts every ticket into an embedding, and LangChain stores those vectors in memory. When a new message arrives, Similarity Search retrieves 5 labeled examples. The message and evidence go to the chat deployment. Pydantic requires 3 validated fields: a label, a confidence value, and 1 short reason. Finally, our code applies its own guardrail. Weak, tied, or low confidence evidence sends the ticket to a person. Retrieval and classification remain separate. If a route is wrong, we can inspect whether retrieval supplied poor evidence or the decision. Model ignored good evidence. Always load secret keys from the .env file. Never write them directly in the code. Our dataset has 60 synthetic examples, balanced across 3 teams. Billing includes charges, refunds, invoices, and subscriptions. Account covers login, passwords, verification, profiles, and workspace access. Technical covers crashes, integrations, file problems, and broken features. This is enough to teach the architecture, not prove a business case. Real tickets are noisier, less balanced, multilingual, and privacy-sensitive. Teams also need shared label definitions. If people disagree about where a cancellation belongs, the model cannot fix that inconsistency. Good AI engineering starts with honest data boundaries. An embedding is a numerical representation that makes semantic similarity searchable. It can place charge twice near duplicate payment even when the wording differs. Build Router creates Azure OpenAI embeddings through LangChain. Ticket Router converts every example into a document. The request becomes page content, and the team becomes metadata. In Memory Vector Store, embeds and indexes all 60 documents. The store rebuilds at startup, which keeps this lesson small. Production would persist and version the index. Vectors are useful coordinates, not human explanations. Index and query text must use the same embedding deployment. If the model changes, rebuild the index rather than mixing vector spaces. For each incoming ticket, Similarity Search retrieves 5 close labeled examples. This is not a web search or knowledge-based retrieval-augmented generation system. We are retrieving demonstrations of the classification boundary. The context lists each label followed by its example text. Now the decision model sees the request and concrete evidence from our dataset. That creates an observability surface. When a route looks wrong, inspect retrieval before blaming the prompt. 5 neighbors is only a starting value. 1 can be a coincidence, while too many add noise, latency, and token cost. Evaluate several values against held-out tickets. Defaults begin an experiment. They do not end 1. Software should not scrape a team name out of a paragraph. Ticket decision is a pedantic schema with exactly 3 labels, confidence bounded from 0 to 1, and 1 short reason. With structured output, asks the Azure Chat deployment to follow that. Contract. LangChain composes the routing prompt and structured model into one. Decision chain. If the response is a dictionary, Pydantic validates it again. The prompt defines team boundaries and tells the model to lower. Confidence for weak evidence or multiple intents. A free-form answer can change shape between requests. The schema protects downstream code from format drift and rejects impossible values before they enter the routing queue. Language models can sound certain when evidence is mixed, so the model does not get the final word. Our code counts labels among the 5 retrieved examples. If the model chooses technical but only 2 examples, support technical. Retrieval support is 40%. Final confidence is the smaller of model confidence and retrieval support. A 60% threshold decides whether automation is allowed. A tie between the strongest labels also forces review. This score is a guardrail, not calibrated probability. Production thresholds must come from held-out data and the real cost of stakes. A higher threshold creates more human work but fewer risky routes. The operating point is a product decision expressed in code. Now follow the verified application from configuration to output. The app loads its Azure configuration from .env before creating either client. Secret keys stay outside the code, and missing settings produce a clear error. The imports reveal the architecture. LangChain supplies documents, the prompt template, the vector store, and both Azure connectors. Pydantic supplies the validated output model. Ticket decision restricts the label to billing, account, or technical. Confidence stays between 0 and 1, and reason remains short. Retrieved example records, debugging evidence. Root result keeps the final label, capped confidence, review flag, explanation, and retrieved examples together. The routing prompt gives the model one precise role and defines each team. The human message contains the ticket and retrieved examples. Build decision chain connects that prompt to structured output. Inside ticket router, each labeled request becomes a document. Text becomes page content, and the known team becomes metadata. The vector store embeds these documents once for the current process. Root rejects empty messages and invalid thresholds before any model. Call. Similarity search returns the configured neighbors. We format them as evidence, invoke the decision chain, and validate dictionary responses with Pydantic. Then our safety logic takes control. Countermeasures how many retrieved examples support the selected label. Final confidence is the smaller of retrieval support and model. Confidence. A tie or a score below the threshold requires review. Build router reads the key and endpoint from .env, creates both Azure clients and injects them into the router. Finally, 4 unseen messages run. Refund goes to billing. An expired verification link goes to account. A PDF export crash goes to technical. The mixed password crash and payment request crosses several boundaries. Its confidence falls to 40%, so the application prints review required. That is the intended safety path. Unit tests should not spend cloud credits or depend on a live key. Deterministic fake embeddings and a fake decision chain verify clear. Routes, mixed intent review, empty input, invalid thresholds, invalid neighbor counts, and the required endpoint. All 6 tests pass. They prove control flow, not model quality. Real evaluation still needs held-out tickets, per-class metrics, review rate, latency, and cost. Production adds privacy controls, de-identification, persistent storage. representative evaluation, monitoring, and versioned releases. This cloud design sends ticket text to the configured Azure resource. So, confirm permission, access, retention, and data handling requirements. Add timeouts and controlled retries. During an outage, use the manual queue instead of guessing. Monitor latency, cost, class distribution, review rate, and corrections. Keep the prompt, examples, deployments, threshold, and evaluation report together as one reproducible release. You built the complete loop. Embed examples, retrieve evidence, request a validated decision, cap confidence, and send uncertainty to a human. Keep the pattern simple, build narrow, expose evidence, constrain output, test the code, and design for failure. Next, we will map the learning path behind this system.